So yeah, so I'm going to talk about the NEP Hard X-ray Survey with Hard XC. So let me jump right into it. So it's an Hard XC is an X-ray telescope. And before I start talking, I guess I would spend one slide mentioning why we think X-ray would be a good idea if you care about AGNs and galaxy coevolution stuff. So this is a figure from the review paper by Hickox and Alexander 2018. So it's basically showing the panchromatic spectrum for AGN host galaxies. And you can see different components from AGNs and or galaxies. So on the x-axis, the more to the right, you have stronger AGN dominance. And if you're on the y-axis shows that, shows how much obscuration you have and how different combination of these two parameters would be manifesting to their spectrum. So as you can see in the optical wavelengths is sort of the blue line. Optical wavelengths is a pretty good tool to study these AGNs. But if your AGN is not strong enough, or if your AGN is obscured, optical sometimes doesn't work that good. And for infrared, it's a pretty good tool to observe heavily obscured AGNs if you have a pretty strong AGN. But if your AGN is not very strong, sometimes your host galaxy star formation emission can outshine your emitting frame emission. So I would say, well, in a lot of cases, if you have an X-ray corona, then hard X-ray would be, I would say, the most pristine indicator of having an AGN. So that's why we, personally, I find X-ray to be a pretty good tool for selecting AGNs. So the telescope that I'm going to talk about is called the Mikhail Pavlinsky Astronomical Röntgen Telescope X-ray Concentrator. It's a mouthful, I know, but RXC is actually one of the two instruments on board the Spectrum Röntgen Gamma X-ray Observatory. The other telescope on SRG is eROSITA, and RXC is the Russian counterpart of the eROSITA. It's a hard X-ray telescope, and it's named after its PI, Mikhail Pavlinsky, who unfortunately passed away earlier this year. So RXC is an X-ray telescope. For those who are not familiar with how X-ray telescopes works, basically you have X-ray mirrors. Basically you have one, you need to have grazing instance of these mirrors so that you can focus the incoming X-ray photons. So the telescope RXC is comprised of 7 mirror modules. Each mirror module is comprised of 28 nickel cobalt shells, and is designed and fabricated at Marshall. So this is another, I would say, probably the last slide showing how the telescope looks like. Basically, you can see that there are 7 telescopes co-aligned, and if you Google a picture of SRG, you will find that in addition to eROSITA, there's these tube-like telescope that's RXC. So a little bit of a history. Marshall originally built 4 mirror modules for EKI, which I think there was some political issues involved, so that one of the guys at Marshall had to take the check from EKI and then personally go to a bank to cash the check. But anyway, a few years later, EKI decided to order 3 additional telescopes, but this time instead of paying there's an agreement so that people at Marshall will have access to some of the data right in the survey. So RXC along with Rosita was launched in summer last year. It's launched to the L2 halo orbit. So it took about 3 to 4 months to fly from Earth to L2. So during, the reason that the telescope is placed at L2 is because it ensures high observation efficiency, and it wouldn't suffer from the varying magnetic structure of the Earth's magnetic belt. So just a little technical details of how RXC performs. This is the 4 weeks half maximum and half power diameter for RXC. It's the centroid of the PSF is about 16 arcsecond, and the half power diameter is about 30 arcsecond. These are slightly better than what NuStar is capable of, but due to the design of the strip detector, the angular size of the pixel is larger than what NuStar has. And in terms of the effective area, RXC is about, I would say, 2 times less sensitive than NuStar across the scientific band of RXC between 5 to 30 keV. So this is a comparison between the RXC effective area and NuStar effective area. So the curve showing here is a comparison between the combined 7 telescope effective area with those from NuStar. So during the trip from Earth to L2, RXC looked at a number of different targets. So this is a image comparing what you can see from RXC and what you can see with NuStar at Galactic Center. So it's due to its superior field of view, you can see that RXC can take a pretty nice image of the Galactic Center in just one shot, which NuStar would require a couple of days to cover the entire field. So this is another performance verification data, which shows basically how the 7 telescopes co-aligned so that we can safely combine the data from all the 7 telescopes. So this is another image basically showing the image quality of RXC. As I mentioned earlier, RXC has a larger detector size, so that's why the image looks a bit blurry. But keep in mind that the event list image displayed here are not exactly in the same format. So anyway, the pixel sizes are slightly different, but it's not as dramatic as what you're seeing here. So this is another performance verification of the Crab Nebula. So in the top row of the images, you can see a series of detector image of the Crab Nebula placed at the various off-axis angle, and you can see some of the. So in the center, you can see a pretty bright X-ray source that is the Crab Nebula, and there are different off-axis angle observations, basically trying to verify that we know the off-axis angle performance well. We know the vignetting function of the telescope well, and we also worked out its phase by working on its light curve, and the accuracy is pretty good. The timing accuracy for RXC is also pretty good. So now back to, well, once RXC reaches L2, it started the all-sky survey. So the plan is to survey the entire sky every 6 months. And during the planned 4-year all-sky survey mission, RXC, along with Rosita, will survey all sky 8 times. So the image you're looking at is a simulated exposure map of the completed all-sky exposure map of RXC. So I placed center of the image at the NEP, where you can see some of the darker spots there, which means those are the area that will have deeper exposure. And Marshall will have data right to the NEP region through the cooperative agreement that I mentioned earlier. So by the definition of NEP is the 200 square degree area centered at the NEP. And because of the orbit of the telescope, it's gonna be it's gonna have the deepest coverage. Well, NEP and the South Ecliptical will both have the deepest coverage in the all-sky survey. So simulations basically suggest that NEP, even though it's only about 0.5% of the sky, but 10% of the RXC sources will be found here. So this is another simulation that we did before RXC went up, which the image you're showing here is a redshift versus 10 to 40 keV actual luminosity distribution. The blue dots are from the SwiftBat 105 months survey, and orange dots are from the NuSTAR Serendip survey. As you can see, SwiftBat is a shallow all-sky survey, and NuSTAR Serendip survey is a deeper but much narrower survey. So the gap between these two is where the RXC NEP will fill in nicely. So this is another simulation results. Basically, we just select objects with red, white color, and using their optical colors, did a very quick SCD fitting, figure out their luminosity, and sort of try to see how many objects that might be detected by RXC. And we also simulated its spectrum. We're not, so we haven't completely figured out the background level from the real data yet. So right now, this is from simulations. But let's go back to the first image I put in my presentation. So this is the all-sky survey, and there's a website where there's an interactive all-sky map. You can sort of scroll around. The sources identified using eKeys algorithm would also be highlighted, but those are detected using algorithms developed for all-sky surveys. I'm not sure how effective those are for the NEP regions, though, but you are certainly more than welcome to have a look. It's quite interesting and pretty exciting. So the last few slides, I'll quickly go through what's happening in RXC in NEP. So NEP is divided into different sky tiles. Each tile is about 10 square degrees. And the top right image is just the scatter plot of all the events we have so far. The bottom plot is just showing how the detector moves across the sky. So each image, well, I guess each snapshot, between each snapshot is about 1 second. So detector will be slewing across the sky as RXC surveys the entire sky. So we use the survey data from the different sky region, which has a bright X-ray binary, to see how well can we localize sources detected in survey mode. So the answer is pretty good. And all the 7 telescopes have pretty similar performance in terms of astrometry and PSF. And the astrometry between optical position and this target is also pretty close. So lastly, this is the, but not least, is the image in one of the sky tiles centered at the NEP, where it's gotten the do discover so far. So as you can see, we're still working on background subtraction, and source detection is also ongoing. So stay tuned. And this is zooming for one of the source here, NGC 6552. And so this is my last slide before my conclusion. Basically, we are doing a lot of stuff, and NEP data prepared by Marshall will be released through HESARC. And I'll leave my conclusion here and take questions.
Thank you very much. There is a question from Tomogoto. Any new hard X-ray source in the first ASS?
So we are still working on basically characterizing the background levels from the particle background in X-ray in L2. So before we can truly pin that down, we run our images through various source detection algorithms, and we have different versions of source lists, but we're in the process of verifying those. Some of them are on the known bright X-ray sources, such as the one I just showed, NGC 6552. Now there's SwiftBAD candidates in the area, but we don't have any certain discoveries on new hard X-ray sources yet. Before we can, I would say, better our background subtraction and source detection, I would say stay tuned. I can't really answer that right now.
The first one is already deeper than the SwiftBAD. Do you expect the first Oscar survey is going to be deeper than the SwiftBAD?
Well, the energy area is not entirely the same. So NGC 6552, for example, that I just showed, is not super bright in SwiftBAD, but it's well, it's comparable, but not directly comparable. So it's kind of hard to say. But I would say the first, at least in the tile that I showed, we have data deeper than SwiftBAD, but not the 200 square degree full NEP area, because it takes 4 years to reach the depths that we want.
Okay. Okay. There is another maybe comment from Tomo. So you say
maybe we can go to Miyaji-sensei.
Okay. Okay. Maybe this question from Miyaji-san. With the photons at NEP, including the EG, in public or just the source list?
Sorry, I didn't get the question. Could you say that again?
Okay. Will the photons at NEP be public or just the source list? So EG background. So yeah, including. So the question is, will the photons at NEP, including background, be public or just the source list?
So if I understand correctly, all the photons in all the events in the NEP will be made public, not just the source list. If that's a question.
Miyaji-san, would you like to say something? Okay.
Thanks. That's what I wanted to hear.
Okay. Yeah.
Okay. Then also, Tomo commented that his collaborator has 3 AGN candidates from the Akari IR. So it would be interesting to compare with Art XC. So it's a comment. So maybe please continue discussing to discuss in
Yeah,
the
definitely. Feel free to contact me if you want to know, a certain sky position has anything interesting